we've already covered half of the scope for this quarter. At this point, we will open a new lesson and we will learn another type of sequence. But before that, let us be familiar first with our target competencies. Let us start with this scenario. Pyramid schemes for making money are a widespread phenomenon since 1980. The operation of a common pyramid is shown. The number of persons on each level doubles. So, if each person on each level continue to recruit other investors, the pattern goes on. The question now is, what do you think best describes the numbers presented on the given scenario? Well, obviously, that is our main focus today, and you may be thinking already that it is an example of a geometric sequence. I want you to ponder on with this question as we go through our lesson. How will you differentiate the numbers on the previous scenario with this new set of numbers? And to help you understand and answer the posed question, let us begin with the definition. A geometric sequence is a sequence in which the succeeding terms are obtained by multiplying the preceding term by a fixed number called the common ratio. It is of the form a sub 1, a sub 1r, a sub 1r squared, a sub 1r cubed, a sub 1r raised to 4, a sub 1r raised to 5, up to a sub 1r raised to n minus 1, wherein a sub 1 is the first term and r is the common ratio. The nth term of the sequence is a sub 1 times r raised to n minus 1. Say for example this sequence 2, 4, 8, 16, 32, 64, 128, and so on. Remember the pre-activity folding field? This sequence was formed through the number of pieces made through each cut you do on your sheets of paper. Showing that it is really a geometric sequence with common ratio of 2, we can prove that each term are correct by the definition. Let us take another example. Determine whether the given numbers can be the first 5 terms of a given geometric sequence or not. If so, give the common ratio. First set, we have 1, 3, 5, 7, 9, and so on. For us to know if it is a geometric sequence, let us determine if it has a common ratio. Using the first and second term, we have r is equal to 3. While if we will be using the second and the third term, the value of r will be 5/3. Since the computed ratio using those two pairs are different, therefore, the given list is not a geometric sequence. In fact, it is an arithmetic sequence with common difference of 2. Second set, we have 3, 6, 12, 24, 48, and so on. Determining again if it has a common ratio, we use the first and second term, which gives us r is equal to 2. On the other hand, using second and third term, we come up with the same. Make sure that the ratio which can be computed using each pair of consecutive terms are constant. And with this example, we can conclude that the given sequence is a geometric sequence with common ratio of 2. On the last set, we have negative 162, 108, negative 72, 48, negative 32, and so on. Solving again if it has a common ratio, we use the second term and the first term, leading us to the value of negative 2/3. On the other hand, Using the second and the third term, we come up also with negative 2/3. Do you think negative 2/3 is the ratio of each term on the list? If you answered yes, you are definitely correct. Since the common ratio of this sequence is negative 2/3, the given sequence is a geometric sequence. Another problem we have: find the 8th term of the geometric sequence 24, 12, 6, 3, and so on. Given on the problem are the first 4 terms of the sequence, which will give us the first term, 24, and the common ratio, 1/2. The value of n is 8, since we are to get the 8th term. To solve for the unknown, we will be using the general term of the geometric sequence, which is a sub n is equal to the first term times the common ratio raised to n minus 1. Substituting the given, we have a sub 8 is equal to 24 times the quantity of 1/2 raised to 8 minus 1. Simplifying n minus 1, we have the exponent 7. And simplifying further the part with the exponent, we have 1 over 128. Lastly, multiplying 1 over 128 by 24, we will come up with the 8th term, which is 3 over 16. If the answer is a fraction, always express it in lowest term. Going back on your activity, fold and fill, you fill in some missing terms of a given set of numbers through some hints in a puzzle. The given sequences are categorized as geometric sequence, and those missing terms are the so-called geometric means. By definition, geometric means are the terms between any two given non-consecutive terms of a geometric sequence. If a sub 1, x sub 1, x sub 2, x sub 3, x sub 4, up to x sub m b form a geometric sequence wherein m is greater than or equal to 1, then x sub 1 up to x sub m are the m geometric means between a and b. If m is equal to 1, the geometric sequence that will be formed is a, x sub 1, b. The number x sub 1 is called the geometric mean between a and b. Thus, it can be solved through the formula x sub 1 is equal to positive or negative square root of the product of a and b. Sample problem on solving for a missing geometric mean of a given sequence. What is the geometric mean between 7 and 63? On this problem, we may take the value of a as 7 and the value of b as 63. And obviously, the unknown is x sub 1. We will be using the formula x sub 1 is equal to positive or negative square root of the product of a and b to solve for the unknown. Substituting all the given, we have x sub 1 is equal to positive negative square root of 7 times 63. Multiplying those quantities under the radical sign, we have 441. Solving for x sub 1, we will take the square root of 441, and that is 21. Since we are taking the square root of the number, we will accept both positive and negative value for x sub 1. Meaning to say, if the arithmetic mean is positive 21, we may say that the common ratio is also positive, which is 3. While if we take negative 21 as the value of x sub 1, the common ratio is negative 3. Another example wherein we are to get more than one geometric mean. Insert 4 geometric mean between 32 and 243. The given are the first term, which is 32, and the sixth term, which is 243. Since we are to solve for 4 geometric means, the unknown are the second, third, fourth, and the fifth term. Solving this problem, the first thing we have to obtain is the value of r, since we cannot solve for the missing terms without it. The formula that we will be using is the general term of the geometric sequence a sub n is equal to a sub 1 times r raised to n minus 1. Substituting the given, we have 243 is equal to 32 times r raised to 6 minus 1, which can be simplified further as 243 is equal to 32 times r raised to 5. Dividing both sides by 32, the next line of the solution will be 243 over 32 is equal to r raised to 5. And to solve for the value of r, we will be taking the fifth root of the numerator and the denominator. So, therefore, the common ratio of the given sequence is 3/2. Next step, to actually solve for the missing means, we will go back and apply the definition of the geometric sequence, which is we can obtain the succeeding terms by multiplying the preceding term by the common ratio. Solving for the first mean, we have for the second mean, for the third mean, and for the last missing mean. Therefore, the four means between 32 and 243 are 48, 72, 108, and 162. And that's it. Thanks for listening again on our Mathematics 10A discussion. I am hoping that you are learning more and more on our class, and that you will be able to apply everything you've gained from this lesson on our activities. Good day again and God bless. See you on our synchronous session.